So we're going to move into 8.5, which is adding and subtracting rational expressions. So what you have to do is remember rational expressions are just expressions that are fractions, and these happen to have variables in both the top and the bottom, polynomials in the top and bottom. So we're going to follow the same rules of fractions that you always have. If I add two fractions, what has to be true? Common denominator. So if I say, have an expression like this, a over b plus b over c, that's equal to, I have this common denominator of c, that stays the same, and then I have the numerators, a plus b on the top. Same for the subtraction. I have a over b minus b, a over c minus b over c, then c is my common denominator, that stays the same. And I subtract the numerators, and I get a minus b over c. So that should look pretty familiar. You've been doing that for a long time. We're just going to add letters. Okay. So we're going to start out easy and move you into it a little bit, and then we'll get a little tougher. But if I have 3x over 5x squared plus 12 over 5x squared, what's my common denominator? 5x squared. So I say this equals, okay, I have 5x squared on the bottom. That doesn't change. I look at the top, I've got 3x plus 12. Can I simplify that anymore? I could factor the top and just check. So that would be 3 times x minus 4 over 5x squared. Still doesn't simplify any. So we're done. And I would take either of those two as a solution on your assignment. Okay, so let's look at the second one. We got 4x over x minus 2 minus x over x minus 2. What's my common denominator? X minus 2. Remember, you can put that in parentheses. So I've got x minus 2. That whole thing is my denominator. So I take my numerators and I say 4x minus x. Well, can I simplify that one? Okay, 4x minus x, that would be 3x. So I've got 3x over x minus 2, and I can't simplify that anymore. So that's not too bad. Always just double check to make sure you can't simplify it. You can start with a common denominator. Should be pretty straightforward. We have a few of those. So questions there. Okay. Now we get into the more interesting part. So what happens when I don't have a common denominator? You have to find one. Okay. And to find the least common denominator, which is what makes your life the simplest, if you can find the least common denominator, what we're going to do, I'm going to give you a process, which, by the way, anybody just looking at that, can you tell me what it's going to be? 18. 1, 6 plus 2, 9. It's going to be 18. So we know this ahead of time, but I'm going to give you a process to do it. So when we add the letters, you can follow the process. So here's what we're going to do. We're going to take both of our denominators. We're going to write down 6, and we're going to factor it. That's 2 times 3. We're going to write down 9, and we're going to factor it. That's 3 times 3. Okay, so now I look at the factors form of the 2, and I say, okay, what factor do they share? They share a 3, so I'm going to put a box around those two. Now, to find the least common multiple, this should look familiar. LCM, least common multiple. What I do is I take all the factors, but the ones that are shared I only use once. So I have a 2, I write that down. I have a shared 3, so I only put one of those down. And then I have another 2. Okay, everybody see what I did? You use all the factors, but the ones that are shared, you only use them once. Okay, so when I take 2 times 3 times 3, that's 18. Okay, so now when it comes to finding the common denominator, you can use that factored form. You look over here and say, okay, 6 plus 2 times 3 3. So when I look at all factored out, my least common multiple, what's missing that I need to multiply 6 by to make 18? I've got this 3 left all by himself, so I say I'm going to multiply the top of that fraction by 3 and the bottom of that fraction by 3. Okay, so then I look at 9. Okay, well 9 was 3 times 3, and I say, okay, what was left over? Well, that was the 2. So I take the top and the bottom of that fraction by 2. Now, why do I always have to multiply the top and the bottom by the same thing? Because 2 over 2 is equal to 1. So I'm not changing the value, I'm just changing the form. Okay, so 3 times 1 is 3, 6 times 3 is 18, 3 times 2 is 4, 9 times 2 is 18. Now I have a common denominator, so I add the numerators, and I say 7 over 18. That won't simplify, I'm done. Okay? So that gives us a process that's going to work no matter how many different weird factors we might have. So let's look at the second one I have here. 4 over x squared plus 5 over x. What's going to be my common denominator? X squared. But we're going to do this little process real quickly anyway. All right, x squared and x. X squared is x times x. So they share an x. So then when you write it down, it's x times x, which is x squared, which is a little overkill in this one, granted, but just to see the process, okay? Because in the next page, we're going to need the process. Okay, so I don't have to change this first one if x squared is my least common denominator. So I have 4 over x squared. That didn't change. Okay, so I look here. To make the denominator x squared, I'm going to multiply the top by x and the bottom by x. So I get 5x over x squared. Now I have a common denominator of x squared. I add my numerator, so I have 5x plus 4 over x squared. Doesn't simplify, we're good to go. Questions? Good to go. Okay, so now we get to do the interesting. Okay, so number 5. I have 9x squared plus x over 3x squared plus 3x. Okay? I see I do not have a common denominator, so I'm going to write those two terms and factor. I'm going to leave the 9x squared alone for just a minute, and I'm going to write 3x squared plus 3x. But let's factor the second one first. 3x squared plus 3x. What's the greatest common factor? 3x. When we factor it, say 3x times x plus 1. Okay, so now let's come back to the 9x squared. I can write 9x squared as 3 times 3 times x times x. Now, if something in there matched, if it's I factored out a 9x squared, you really wouldn't even have to factor out that single term. But since it doesn't match everything, I got to do that. Okay, so let's look at this. We've got 3x in both of them, right? So this is the ones that are shared. Okay, so let's write down the factors that we've got. 3 times 3 times x times x. Now the only thing that, and if it helps, you can kind of cross out that second one so you know I only use this 3x one time. So now I can skip to x plus 1. Everybody with me on that? Does that make sense? We just did the same thing we did before. You factor it. Factoring is wonderful. It helps you make good decisions. So our final, all these single terms, I can multiply those together, and I get 9x squared times x plus 1 is going to be my greatest common factor. Okay. Now, when you're doing your assignment, the first part gives you some expressions to add that already have these common denominators. The second section asks you just to find the least common multiple of two expressions. On those, in that section, all you have to do is just right here and quit. Okay? And then the last section, of course, then you're going to get to add the ones that don't already have common denominators. So let's move forward with that. Okay. So I'm going to rewrite this one because there's not room to do the multiply thing here. So this is going to be 7 over 9x squared. So now when I compare it to my least common multiple, what factor is it missing? X plus 1. So that means I'm going to multiply top and bottom by x plus 1. Plus. Now I've got x over. Now, just to make life a little bit simpler in choosing my factors, I'm going to write this in factored form. So this was 3x times x plus 1. So this and this are the same thing. I haven't changed that. When I look at it like that, what is missing that I need to multiply this one by? The 3x. Okay? So I've got this one, I've got this one, I've got this one. So I've got to get this one and this one. Okay? So I've got multiplied by 3x on the top and the bottom. Okay, I now have a common denominator. Now, before I can add these, I'm going to have to distribute, multiply out the top in order to be able to add them. The bottom, I want you to leave it factored. Don't FOIL that part out. Denominators, leave those factored. So now I have 9x squared times x plus 1. On the bottom, on the top, I have 7x plus 7. Plus. Okay, on the other side, I have 9x squared times x plus 1. X times 3x gives me 3x squared. Okay, so multiply out your tops, leave your bottoms factored. I'm running out of room. Move this guy out of the way. So finally, I get to just add together my numerators. So I've got 3x squared plus 7x plus 7, and it's all over the common denominator of 9x squared times x plus 1. Questions? Okay, now you do have to double check here. Take this top, see if it will factor. It starts with a 3. There's no greatest common factor to factor out. So I'd say 3x squared here, a 7 here. 3x squared times 7 is 21x squared. Are there factors of 21x squared to add to my middle of 7x? There isn't. So that top isn't going to factor. You're not going to simplify that one any further. So you just circle it right like that. Okay, leave the denominator factor. Questions on that one? Now we get to do the last one, which is always the most interesting. So let's look at it. Get us some room on this. Okay, so this is a subtraction problem, which adds another thing you got to keep track of. Plus and negative signs always can be a little bit tricky. Okay, so I have x plus 2 over 2x minus 2 minus negative 2x minus 1 over x squared minus 4x plus 3. So let's first take our two denominators and find the least common multiple. I'm going to write 2x minus 2. I'm going to write x squared minus 4x plus 3. Find the least common multiple. Okay? Factor the first one. Common factor of 2. I have 2 times x minus Okay, what do they share? What factor do they share? X minus 1. Okay, we're going to do this. Okay, so when we write them down, we're only going to write one of them. So here we go. We got 2 times, we got to use one of those, so x minus 1 times x minus 3. So since that one was shared, I don't use the x minus 1 a second time. So there's my least common multiple of those two terms. Okay? Okay, so now let's do step 2 over here on our fraction. So I got x plus 2, and I'm going to write that in parentheses because I'm going to be multiplying it by stuff. I'm going to write my denominator in factored form because that makes it easier to see what I'm missing. So when I have 2 times x minus 1, what factor am I missing over here? X minus 3. I multiply top and bottom by x minus 3. Minus. Okay, so then I've got on top negative 2x minus 1. On the bottom, I've got x minus 1 times x minus 3. What's that one missing? 2. So actually, I'm going to put that at the beginning statement because it's easier. So I'm going to say times 2 on top and bottom. Now I have my common denominator. What's the next step? What do I need to do? Multiply the stuff on the top. Multiply out the numerators. Because I got to do that before I can add them together. Okay? So let's look. When I say 2x plus, or x plus 2 times x minus 3, how do I multiply those two? I got to FOIL it. I've got 2 times x minus 1 times x minus 3 in the denominator. That's not going to change. Leave it factored out. But on the top, you're going to want to FOIL. So I've got x times x is x squared. X times negative 3 is negative 3x. 2 times x is 2x. 2 times negative 3 minus 6. Okay? Second term. Denominator stays the same. Okay, I gotta multiply the numerator. So 2 times negative 2x gives me negative 4x. 2 times negative 1 is minus 2. Now we're set up to subtract. We got the common denominator. Now here's what I would do, and this is not a requirement, but it just makes it less likely you'll make a sign error. If this is minus this whole thing, that means that negative has to be distributed to every term in there. So what I'm going to do, negative times negative is positive. Negative times negative is a positive. So now I can just add things up, and I don't have to worry about keeping track of signs. So distribute that negative before you start combining these. Okay, so now let's see. I have just one x squared, so let's write that down. Now, I've got a minus 3x plus 2x plus 4x. If I combine all those together, what do I get? Plus 3x. Okay, so then I have a minus 6 plus 2. So we go, not plus, it's going to be a minus 4, right? And that's all over. Last step, we got to factor the top, see if I can simplify this. This one actually does. So x squared plus 3x minus 4 is going to be x plus 4 times x minus 1. Still over my nice factor denominator. 2 times x minus 1 times x minus 3. And I see I have a factor that's common to the top and bottom. So I can cross out my x minus 1. Final answer. final answer. Questions? Okay, good to go.